For today's lesson, we are going to work with congruent triangles, and we're going to be doing a two-column proof. So the first thing they always do is they give you some information and they tell you what you need to prove. So we'll look at what we're given. So it says E is the midpoint of line segment AC and BD. Line segment AB is congruent to CD, and line segment AB is parallel to CD. So we need to prove that triangle ABE is congruent to CDE. So the first thing I'm going to do is let's make a sketch. So we know that if something is the midpoint, we need to have some kind of line that is going to be the midpoint of, right? It's an ugly drawing, but we'll go with it. So we have A, B, C, and D, and we'll call this E. So it says E is the midpoint of AC and BD, which we have, kind of. AB, this line right here, is congruent to CD, and it is also parallel. Okay, so if you're looking at your book at page 242, number 11, you can follow along, and it gives you our two-column proof. We have our statements over here, our reasons we're going to fill in. So the first thing it says, number 1, AB is parallel to CD. If you look over in your givens, that is one of the things that you're given. You're given that AB is parallel to CD, and we actually already drew that. The second one, it says angle ABE is congruent to CDE, and BAE is congruent to DCE. So we'll go and look at this. We'll go ahead and draw it. So ABE is congruent to CDE, and BAE is congruent to DCE. Alright, and if you notice something about this, I have two parallel lines, and I have two lines that cross them or are cut by my transversal. So AC as well as BD are both transversals. So if you look at this, we know that B and D as well as C and A, they are alternate interior angles. So we'll go ahead and write that down. So they are alternate interior angles. Next one we have to go to 3. It says AB is congruent to CD. We look over here in our statement, that is given to us. So 3 is given. Next one, 4. It says E is the midpoint of AC and BD. That is also given. This one's pretty easy. 5 I didn't fill in, but 5, it says, if you look in your book, the thing that it gives you is definition of a midpoint. So if we look back over here, we know that if it's a definition of a midpoint, that means that AE is congruent to EC, and that DE is congruent to EB. So we'll go ahead and mark that, and then we'll actually write this. So we have line segment AE is congruent, make our little sign, to EC, and line segment DE is congruent to EB. That is the definition of a midpoint. Next one says 6. Angle AEB is congruent to CDE. So we'll go ahead and draw this. So AEB is congruent to CED, 2, 3. And if you actually look at that, you have our two parallels cut by transversals. These are vertical angles. So go ahead and write that down. 6 are vertical angles. Okay? And our last one, 7, says triangle ABE is congruent to CDE. And if you look at it, the angles are the same. This side's the same, this side's the same. These angles, and that side. I know that this is the definition of congruent triangles. All right, and we have successfully finished this 2-column proof. Any questions? Go ahead and ask. Good luck on your next one.